All right, I wanted to show you my test harness here. This is for the purpose of optimizing the Qi charging on this unit. So the key thing that we want to do is discover the best values for CS, which is C41, C42, and C43 inside here, that optimizes the current draw in this kind of harness configuration. So over here I have a power supply, and what this power supply is doing is basically delivering a fixed voltage under a maximum current draw of 0.3 amps. So what you see inside here is a cut battery and a battery connector that is connected to this power supply. And what I have is that the device is sitting on a Qi charger with the Qi charger active. And in addition to this, the Qi charger's cable, which is over, let's see here, okay, is wired in series with an ammeter. So we can measure how much current is being drawn by the Qi charger through the presence of this, this device. So what we're finding, it should make sense if you think about it, is that depending on what the physical configuration of the device is, of this coil inside, you'll change the values of that the ammeter reads. So if I just jiggered this around a little bit, and so what I'm going to show you now is that yes, in fact, under different configurations, you'll get different current draws. So the ideal configuration is one which just is unrealistic. So I'm just going to take everything out I can. All right, is this case. So most of our engineering testing that we've been doing has been working with completely naked, unbuttoned devices, which is never going to happen in practice, which is this, all right? The coil sitting right on top. And here you get the most, the least current draw, because you have the most efficient configuration, all right? So if we set it, so again, this is, you can measure the current draw through the cable into my Mac over here. And as you can see, it's like 0.19. If I push down even harder, it's even lower and even more efficient. But we can't go around with this configuration when we have our devices being charged up. Now, the actual situation changes. Let's just make it a little more complicated. So I'm going to put, hold on a second, the battery right on top. Okay, so here it is again, battery right on top. So so here, if you put the battery right on top, look, it changed from 0.19 to 0.312 or so. Okay, this is so clear. There's a solid light because we've loaded up the firmware to do that. If we have actually a separation, what I'm going to do is I'm going to add the piece of foam between the battery and the coil. Okay, so here it is. Here's a new kind of sandwich. All right. If you notice over there, that's 0.19, which is back to kind of where we were before, but not exactly. Okay, and again, this is sort of a little bit less efficient because the battery and the PCB are doing something. If I press down on this, okay, so I'm going to make half a burger, you'll see it won't get quite back to the original situation, but it's still less, it's still not as efficient, meaning further away from that 0.19 or 0.18 value. And just to convince yourself that this is in fact interfering, here it is in the naked situation again. And if I press down really hard, you get down to 0.15. Let go a little bit, it's 0.18. And if I put the battery in the situation here, you'll see, we have higher current draw, meaning less efficient. And if I put in the foam separator, we're in a different kind of situation still. Okay. And basically what we need to do is to set up this configuration and get some optimal value. Okay, here it is without, with the sandwich all there, but not compressed. And as we compress, you get sort of less efficient values. Okay. Now the reality is when we have a fully mechanically assembled device, that I will try to do this with one hand here. Here it is. Okay. Then it's even worse. Okay, because there's now some separation between the coil and the Qi charger. Okay, and getting to something as close as possible to reality. Okay, then I'm going to have to work a little harder to do this. Let's see with my hand here. We're around there. Okay, so we have chosen some values which are somewhat reasonable, but I think before we go full into full hardware production of about 1,500 units or something like that, we want to figure out the optimal capacitor value. So this is kind of the harness description. Some details that matter are we need to turn on our power supply, okay? And the power supply, in this power supply configuration, there's a overcurrent protection. The on-off here, basically, when we turn on, this is how you kind of set your parameters. We recommend putting things at 3.6 volts. This should be basically the same 3.6 volts. In this world, you could adjust the values up and down a bit. So 3.6 is kind of like the basic rate for the battery. And then once you get to this point, you can sort of say, turn it on. And on the Qi charger, like this, it actually shows you what's really going, what the current draw is, and it's 0 because it's sort of supplying power. If you lift it off, you'll see the actual current draw being delivered by this power supply. When you put it on, it actually goes the opposite direction, and then you can see it goes to 0. So this is the configuration again. Delivering power supply. Notice that there's a cut battery. Okay, so the battery is not actually delivering anything. It's just there as a kind of physical distraction to the overall system. And the reason why we wanted to have the battery cut and have this power supply deliver through the battery connector is so that we could have a controlled situation when we take these measurements of having exactly 3.6 volts up to a current of 0.3 amps. And then that's accomplished through the battery connector that you see underneath here. Okay, so I will show you next this thing here. So what you see inside this cut situation, is 4 wires. The green and white are data, and black is ground, and red is basically 5 volts. And again, we're measuring the amount of current being drawn here by the device. If you look, let's put this back on here. If you go around and jiggle and say, okay, how does this thing vary as a function of position? The answer is quite a lot. So it'll be a question of how we do this in a controlled way, which I'll talk to you about next.